Hi guys, we're on Unit 3 and we're on Day 5 and we're talking about line segments associated with triangles. One we've already heard about, which is called the angle bisector, but there's two more called an altitude and a median that we have to talk about. But first in the warm-up, it says in the diagram, BA, and that is your perpendicular symbol to BC. And before I read over this, and don't ever come back to it like most people do, we have to remember that perpendicular, remember, gives us right angles. So wherever BA, which is right here, meets BC, which is right here, they're going to form a 90-degree angle. So I'm going to go ahead and put it in my picture before I forget. Okay. Then it tells us that the measure of angle ABD, so again, if you need to highlight to trace over to find it, ABD, so that angle right there has a measurement of 2x plus 18. Okay. And then the measure of angle CBD, which again, if you need to highlight it, C to B to D, that angle is represented as 4x minus 18. Okay, they want you to find the measure of each angle. So common mistake is that people will set these two angles equal to each other because they think that BD is an angle bisector, or it looks like BD is cutting the angle in half. However, there was nothing about that in the question. However, we do know that there's a right angle box, and those two angles are both part of that 90-degree angle. Therefore, those two angles will add up to equal 90 degrees. So we're going to take 2x plus 18, add the 4x minus 18 to it, and that total, part plus part, should equal the whole, and the whole is 90 degrees. Okay? 2x and 4x make 6x. Positive 18 minus 18 actually cancel, and we're equal to 90. We're going to divide both sides by 6, and x should come out to equal 15. And now they want to know the measure of each angle, so we're going to go back and plug in. 2 times 15 is 30, and 30 plus 18 is 48 degrees. Okay. This one is 4 times 15, which is 60, minus 18, which is 42. And so that ray BD there in the middle is actually not an angle bisector, since these measures of these two angles don't come out equal, but they do add up to 90, just like what they told us in the question. Okay, so going down, we're going to go ahead and talk about the altitude. Normally, I would give you guys straight edges today. However, hopefully you have your own. And there is no straight edge tool on my program here. So bear with me on the straight lines. So we're going to go ahead and talk about an altitude. Altitude, I don't know if you guys know, is another word for height. So if you ever heard the altitude of the plane is 2,000 feet above the ground, that means from the airplane straight down is the measurement of the height, 2,000 feet. Okay. When you go to the doctor measures your altitude, although he doesn't call it altitude, he calls it your height. All right, but he is measuring your altitude. So it's a line segment drawn from any vertex of a triangle. Because it's measuring height, it has to go straight down to the floor, aka you have a vertical line that measures your height and the horizontal floor on the bottom there, and you're going to realize that that line segment has to be drawn perpendicular to the line containing the opposite side. Which, if you think about it, is why the doctor always tells you to stand straight up so that your body is vertical, the floor is horizontal, and you are perpendicular with that floor, forming right angles. And so that's actually what this is going to form. So altitudes form perpendicular lines, and the perpendicular lines form right angles. Okay, so it says draw the altitude from point A to side BC. So if I'm at A and I want to be and represent an altitude, I'm going to go straight down to BC. Okay, and you can see my perpendicular lines, which then form right angles. Okay, so this one is a little bit strange, but if I'm at A and I'm going to go straight down, I'm not going to meet BC. So what we would do in this one is that we would go ahead and extend our line with our straight edge if we had one, and then we would go ahead and form our right angle. Okay, in this very last picture, if we're on A and we're going straight down, you're going to realize that you're tracing along one of the sides of the triangle, and that's because this triangle is a right triangle. And the altitude ends up being one of the sides, whereas the altitude in the first picture is inside the triangle, the altitude on the second picture is outside, altitude on the last triangle is right on. Okay? All right, so altitudes, remember, give us perpendicular lines. And then perpendicular lines give us right angles. Okay, so going on to the next one, this is called a median. And if you ever drove down the thruway or heard that there was an accident on the thruway, someone might have said that, the semi smacked into the median. The median is in the middle of the road. It's that concrete barrier. So in a median of a triangle, it's a line segment that joins any vertex of the triangle to the midpoints of the opposite side. It cuts the opposite side in half or into two congruent segments. Okay, so they want us to draw the median from point A to side BC. So if I'm at A, first off, what I'm going to do is I'm going to go ahead and highlight where I think the midpoint of BC is. So I'm not measuring or anything like that. I'm just eyeballing. Okay, but I'm going to go ahead and say that that yellow dot represents the midpoint. And so when I go ahead and draw in my line, it's going to connect A to the midpoint. And because that's a midpoint, I could go ahead and put tick marks on BM and MC, because if that's a midpoint, then those two segments would be equal lengths. Okay, so same thing in the next picture. I'm going to go ahead and find the midpoint first. So from B to C, I think that the middle looks like maybe around there. So I'm going to put an M here for midpoint, not median. Okay. And now I'm going to go ahead and draw in the median. The median, again, is a line segment that goes from the vertex of a triangle and it connects to the midpoint of the opposite side. And because that's a midpoint, we know that that segment there would be equal to that segment there. Okay. And same thing in the last one. So we're going to go ahead and eyeball where the midpoint of BC is. Oops. And then I'm going to go ahead and draw in my median that connects the vertex to the midpoint of that opposite side. And again, this segment here would be equal to this segment here. Okay. And so that's a median. A median goes to the midpoint of the opposite side. And then the midpoint gives us the two congruent segments. All good stuff. Okay. All right, last one. We've talked about this one before, so this should be nothing new to you. This is an angle bisector. So it cuts the angle in half, giving you two equal angles. So it says a line segment that bisects any angle of the triangle. It cuts the angle in half and terminates in the side opposite of that angle. So it says draw the angle bisector from point A to side BC. So when we draw this line in, all I'm basically trying to do is split angle A into two equal angles. I have no clue where I'm going to go end up on the other side. Maybe will I form perpendicular lines like an altitude? Maybe, depends on the triangle. Okay. Will I be cutting the opposite side in half by going to the midpoint? Maybe in some triangles, but if you're just an angle bisector, the only thing that is really required to give you is two equal angles. Okay, so these two angles here are equal, and I showed you by arc marking them. Okay, we have no idea what happens when that angle bisector gets to the opposite side. Okay, the only thing I can say that an angle bisector does is cuts an angle into two equal angles. Okay, so in the second picture, we're going to go ahead and draw in our angle bisector. We're really just trying to make the angle on the left-hand side of it and the right-hand side of it look like they are equal angles. Okay, so I wanted this angle here to be the same measurement as that angle there. So we could double arc mark them and show that. In the last picture, we're going to go ahead and cut angle A in half. And we're going to go ahead and get two equal angles. There's one. There's our second one. Okay. All right, so an angle bisector, the only thing we can say that an angle bisector gives us is two congruent angles. All right, altitude gives us perpendicular, perpendicular gives us right angles. A median goes to a midpoint of the opposite side, and therefore the midpoint gives us two equal segments. An angle bisector gives us two equal angles. All right, here we go. We're going to go ahead and flip to the back page of our notes, and I'll see you guys there.